So this is the Demystifying Data Engineering series. This is actually the 11th webinar we'll be holding this year. And if you are joining us for the first time, I'll be dropping the link to join the community. But who we are as a community, the data engineering community is actually a community of beginner, aspiring, intermediate, and professional data engineer. We collaborate on project and network and support each other through our data engineering journey. So it's really amazing community. So be a part of us. And today's webinar, it's actually a 2 hours webinar, and you have somebody who I absolutely adore, and I'm a fan of his work. Yeah. So we have Temidayo Omoni. Yeah. He'll be taking us through building enterprise data streaming pipeline using open source and cloud technologies. Yeah, Temidayo Money is actually a senior data engineer and solution architect. Like, he has experience building scalable data engineering pipeline across different industry, just to name it, fintech, gas. In fact, he's a consultant, like he's everywhere. And I really, really look forward to this session. Najeeb can admit to that because when he brought you on, I'll be like, wow, finally something I can relate with. So today we'll be taking us through a foundation of streaming technology, architecting a real-time data streaming system, production ready strategies, integrating with Gen AI, you know, before I finally hand over to him. So I hope we all get something at the end of this session. It's actually power packed. I trust Temidayo would over deliver. So Temidayo, over to you, sir. Boss.
So it's
Yeah.
hey okay, yeah, good evening everyone. Good evening. Thanks Musili for the introduction, and also thanks Neji for the invite. I know there'll be multiple invites. I've always been like, oh, I'm busy and stuff like that. So finally, I guess the year's come to an end. So good evening everyone, and I'll first say a big shout out to Neji. The idea for bringing data community, engineering community, it's amazing. Like this, I think it's the only data engineering community right now that is actually very active, like everywhere I've seen so far. So big one to
Yeah.
Neji and everything you guys have been doing. So early this morning I was thinking what approach should I use, because when I actually dropped the topic, I was thinking I can cover it within 2 hours, but like okay. But what I'm going to do now is I'll drop a GitHub repo to everything we'll be doing, right? So I will appreciate if you guys have documented everything. All the codes I'm using today is going to be there, so we can all follow along as we're doing it. So okay. So so before I start, I remembered the last time my was done something with respect to streaming technology, that's Kafka, right? So it really touched based on the fundamentals, the different components of Kafka and everything. So we might not really go into deep into that, right? So what I'll just do is, from my own experience in the consulting and engineering field and what's so not, right? What I've seen over the years is that most companies are going into either the enterprise route, or they're going into the modern data stack route, or they're going into the open source route. But right now, what I've really noticed from companies I've worked with as a consultant, and also other jobs I've done in the past, is that everyone is doing more of multi-cloud solutions right now. So it's like they're mixing both enterprise, modern stack, or they're mixing both open source and enterprise, like combining everything together. So the idea for this is, okay, how can we unify everything together, right? How can we bring the enterprise technology? And also, I'm very heavy on Azure, OCI, and also and also GCP, right? So for some of you that AWS guys in the house, I'm so sorry. So the technology I'm using for today is going to be more open source technology, right? Azure and also Fabric. So I'm so sorry for everyone that is heavy on AWS. I'm so sorry about that. So sorry. But the thing about it is that all the technology are actually the same, right? Because I've used GCP heavily, and also OCI, that's Oracle Cloud Infrastructure, heavily, right? And bet you me, everything is the same. It might just be different name or different ideology, but bet you me everything is totally different, the same. The Lambda function everyone keeps using in AWS is still the same to use as Azure function, or the S3 bucket is still the same to use as Azure Cloud Storage account and everything. So basically everything is the same, right? So what I'm going to do now is so because of I don't want to like start going too deep into fundamentals, because of it's going to be like more like a practical kind of session. I'll show you how things work, right? So what I'm going to do is I've dropped the a GitHub repo. So in the GitHub repo, I've actually documented everything in total, right? Depth by depth. So you guys can always follow. So what I'm going to share my screen right about now. So my first screen. And just let me know if you can see my screen.
Yes, I can.
Okay, awesome.
Yes.
So in the Git, I'm just showing the GitHub repo for now, right? So in the GitHub repo, you see that all the code I'm using are basically here, right? All the code from the beginning, from the Docker Compose, the consumer, the producer, basically everything is here, right? So if you go down, also there's a full video if you want to do it. Basically everything you're going to need to actually reproduce this yourself is actually here, right? And also the full architecture. So let me just explain the architecture aspect to you guys, and we can continue from here. So let me just zoom a little bit. So let me give an instance, right? So every company use what we call microservices, what we call streaming technology and everything, right? So the whole idea is we're trying to build a solution that can easily scale, right? That can easily scale, that can always scale, and that can also take data real time. That's streaming data real time. And for all of us here as data engineers, people call us plumbers, right? Because we're always building pipelines and everything. Straight pipeline, T pipeline, everything. We're always building pipelines and everything. So indirectly, we're called plumbers, right? So the idea for this is we're trying to build a solution that can do real-time CDC, but with streaming, right? And everyone knows the concept of the Belgium, right? We suppose CDC, that's change data caption approach. So I'll just explain the entire architecture and how everything works step by step. So the first step is your producer, right? So look at your producer as like a mobile application. Right? So you know that you have a okay. Okay, sorry about that. Am I back? Okay. So am I back? Hello?
Yes.
Okay.
Yes,
I
yes,
don't know why
yes.
my network just went squeezer. Okay. Okay. Okay, let me just explain this, right? So I'm just trying to explain the whole architecture, how everything works before we start the actual project itself, right? So let's say I'm a software engineer, right? I've built a mobile application, I've built a web application, right? Um, when you call yourself a full stack developer, you're basically doing both front end and back end, right? So the front end is what everybody uses. Let me give an example. Like I'm using GT Bank mobile application, for instance. I'm making transaction, I'm transferring money, and I'm doing all sorts of things, right? Whenever I make transaction, whenever I do anything at the front end, instantly, right, data is being transferred to the back end, right? So the process of doing that, we use what we call a connection string. So a connection string is just basically a combination of both your host name, which you call your server name, your username, your password, and also the like just basically like a connection string that helps you connect to the database. So most times you have what we call a connection string, right? So from our front end application, which is a mobile application, right, or a web app or anything, right? Whenever I make any transaction, whenever I do anything, whenever I do any, maybe Facebook or something, right? Whatever action we do is data is sent real time into a database, which call a what do you call it now? Via connection string. That's why most times all this part is not actually done by a data engineer. Most time we do it by the software engineers. But now the way technology is going now, there's a lot of interchange between there's a lot of relationship now between data engineers and also software engineers. So most times I don't even look at myself as a data engineer anymore, because I look at myself more as a software engineer, because of the end goal is actually to become a software engineer. That's just my own thought right now, because the way technology is going right now, you just have to be a software engineer at the end of at the end of everything. So our data coming from the application, data is being sent real time to a database. So the database I'm using an Azure Postgres SQL database, right? It's called a flexible server, right? You can use any database for your CDC, right? But I prefer using Azure Postgres because I'm not putting my database on Docker, which is going to consume me a lot of memory, which I'm trying not to avoid right now. So I'm using what they call the Azure Postgres database, right? So event, or you can call it your producer. So your web application is basically your producer that sends data, that sends event real time to your Azure database, right? Using a connection string, right? So now the idea now is, because I want to build what they call a real time capture of data. And most times, you cannot connect, you can't send data directly from a database to Kafka topic, right? All this terminology, I know Maya have explained all of this, so I don't think I need to start explaining what a broker is, what a replica is, what all of this producer and consumer is, and consumer group. Maya has done justice to that. So for some of us, you might just need to just go back to the video Maya did, and it basically broke down all those processes for us, and he did an amazing job. Actually, I was actually there too that day. He really, really went down. People were asking him a lot of questions, so he really did an amazing job for that. So your concept of this is our data coming here real time. That's like a producer sends data to our Azure PostgreSQL database, right? So now the concept now is that I can't send data from a table to Kafka. It won't work. Why won't it work? Because of two things, right? So most times Kafka consumes two types of data. Is either it's in a JSON format or it's an Avro format. So Avro is just basically JSON files with its timestamp in it, right? And the data must be serialized, right? So those conditions have to be met before data gets to your Kafka topics, right? So now, with that not being met, you can't send data directly from Azure Postgres database to Kafka topic, because Postgres data are basically relational tables, right? That table that rows and columns kind of data, so they can't go directly to Kafka. So that's where the Bayesian came to play, right? The Bayesian is basically an open source that supports CDC approach with database. So CDC stands for Change Data Caption. So what the idea is, whatever data, so look at how it works now. I'm a software engineer. I make an application that sends data to a database. That's all. Front end has been done, back end has been done. But now for people to make intelligent decision, like the machine learning guys, the AI guys, or any other people want to make intelligent decision, they want to get those data real time from Azure, from the database, right? But they can't push that data real time like that um Kafka topic, because why? It needs to be serialized. It also needs to be a non relational table, which is either a JSON or Avro format. So what the Bayesian does is, the Bayesian does two things. It converts the data here into, it makes it serialized. That's from tabular, that's a tabular table to a serialized table. It also do what they call what's the name now? It also convert it to JSON or Avro format, whatever one you prefer, right? So it's a CDC caption. So the idea now is, as whatever changes happens in the database, it reflects real time in your Kafka topics, right? So that's for this part to this part, right? Using the Belgium. Then we have our Kafka topic where we have partition. I also have a replication factor where it's more like for disaster recovery, so on and so forth, right? Then we have what we call our consumer, right? So I'm just using a normal Kafka consumer. So consumer basically consumes data from Kafka topic. Producer produce data to Kafka topic, right? So this is our producer, produces data to Kafka topic, right? Topic is just a table, right? I know my wife explained that the last time. Topics is just a table. So I can have like a table for sales. I can have another table for customer. I can have another table for provider or something like that, right? So topics are just table. So I can have multiple topics with different partitions in it, right? So now what a consumer does is that the consumer consumes those data from Kafka topics, right? So you can create like what you call like a consumer group to consume your data, so on and so forth, right? So what we're trying to do now is, um, for we the core engineers, right, we want to see what's happening, right? So even as we are consuming the data from Kafka itself, we also want to be able to see the data, like visualize the data, right? So that's where things like Kibana and Elasticsearch comes to play. So what is Elasticsearch? Elasticsearch is a NoSQL database, right? It's just like your MongoDB, or you can say your Cosmos DB, right? Or yeah, MongoDB, Cosmos DB, basically any kind of data that gives you this NoSQL kind of format, right? It's that's what we use for Elasticsearch. You can either use your MongoDB, which is very, very popular in Mongo, or you can use Cosmos DB for Azure. That's Azure Cosmos DB, or you can use Elasticsearch, anyone you prefer using. And then we have Kibana. So Kibana just gives you like a visualization. So look at how the core concept works, right? So for the core engineers, that's like the software engineer guys, right? They also want even though the data engineers, data scientists, data analysts want to get the data. Also, them too, they also want to be able to visualize the data themselves. They want to be able to see the data, what's actually happening themselves, right? So what we now did now is that, okay, we're going to create like a consumer that consume data into two places, right? One consumer sends data into Elasticsearch Index, right? So index is also like a more like a topic also too. Like it sends that to Elasticsearch Index. So and you can visualize those data real time inside of Kibana. For the data scientists now, if you work as a data scientist, or if you work with most data scientists, especially the AI engineers, ML engineers, ML ops guys, and everything, right? They will tell you that they prefer working with file kind of data. They don't like working with relational table. I don't know why, but they prefer, if we give them relational table, they rather convert it into like a SQLite or something, right? So they prefer always working with flat files, right? So what they also want, they say, oh, can you make that data a file format and send it to like a storage account? A storage account can either be an S3 bucket, can be a GCP cloud storage account, or can be Azure Data Lake Gen 2 or Azure Blob Storage, right? So we're going to have like two consumers, right? One consumer sends data into Kafka Elasticsearch Index. We have another consumer that sends data real time into Data Lake Gen 2, right? That's the next phase now. So we're going into the engineering and the data scientist aspect now. So how the engineering and data scientists, how did they work down magic? How did they do their own thing? So for the engineering and data scientists, it's basically two things, right? So because I'm trying to still leverage the whole concept of fabrics itself, right? So fabrics are what we call the one lake architecture, which is basically like a lake house, right? Lake house basically gives you the best of two worlds. It gives you more like a data lake and a data warehouse together, right? So it gives you the best of two worlds, right? It gives you the best of a data lake. It also gives you the best word of a relational table. How will I explain it now? Okay, let me just explain via a diagram so it's easier for you guys to understand, right? So if I draw, okay, not this. So if I draw a lake, for instance, tell me if you can see my screen.
Yes, I can. Yes.
Okay, awesome, awesome. Okay, so let's assume this is a data lake, for instance, right? So I'm trying to give you the concept of a lake house, for instance, right? Lake house, right? So lake house basically gives you the best of two worlds. It gives you the best of a data lake and also data. Let me just put it beside it to be easier. Data warehouse, right? So we call it the modern data architecture. So we call it the modern data storage system, the modern data storage system, right? Storage system. So what are we trying to do? By default, right? Because we're doing like a lake house, by default, the data are in a packet format, right? They're always going to be in a packet format, right? So packet are just basically, they call them columnar data, right? The way we have our CSV files, which are like row-based, we also have another which is columnar data. So now, if you read the architecture of a Delta Lake, you tend to understand it better. As if this is more like an advanced class, everyone here are like data engineers already, right? So I know my was done the fundamental part by introducing you guys to Kafka. So I just do more like a real world scenario and how it's being used in a real world approach, right? So this is like more like a lake, right? And on top of this lake, we have what we call a table on top of it, right? A table on top of it. We have what we call a table on top of it. So that's why if you see all those core data warehouse engineers, they don't believe in your concept of a lake house. They say, nah, it's not. It's, but I actually understand them, right? Because there are some things that a warehouse can do that a lake house can't do well, and there's some things that a lake house can do well that a warehouse cannot do very well. So everyone has advantage and disadvantages. But when it comes to streaming approach, I'll always give it to a lake house. It's very, very good in that kind of scenario, right? So if you look at this now, right? Data are going to be put coming here real time also too in the Azure Data Lake Gen 2, right? In a particular container. And you can use a pipeline, right? Or you can use a Python. So from here, you can either use a Python or use a pipeline, but we're using a pipeline. So we're using what called Fabrics pipeline, right? Or you can use AWS Glue, right? Or they call it data flow in GCP, right? Anyone you prefer use it, or I think GCP data fusion, anyone you prefer using, right? So as I tell you that all of them are the same. So when someone say, oh, I know AWS, I know, no, everything is basically the same. So most time I just try to like tell you how all of them work side by side and interchangeably between one another. So now as data comes here, right, you can actually pick data incrementally. So how can you pick data incrementally? Is either you're using 3 approaches. Is that using a concept called picking data based on last modified dates, you are picking data based on store procedure, or you're using what we call data flow, right? You're doing like an offset approach. There's something called an offset. Offset stands for insert and update, right? So for some of you that write a lot of SQL and a lot of Python, so we call it merge in and Spark, right? That's PySpark. We call it offset in SQL, right? So different terminology, but all of them are the same. So you can either use the offset approach, you can use the concept of last modified date, or you can use what we call a store procedure, but can do incremental increase. Then the data comes to a lakehouse. Then you can use your Azure OpenAI API to build like a large
Babe,
language model from this.
this
Okay, so
guy,
for
the guy teaching, right? He's breaking down concepts that I know very well because I'm preparing for certifications. And why he is
praise,
breaking it,
praise your audible. Hello, praise. Okay, cool. Okay, so now the next thing now is if you look at this also too now, right? The same concept also works too now with also the analytical part, right? We have what called the event stream. So if you look at event stream for the AWS guy, look at event stream as your AWS Kinesis, right? For the GCP guy, look at event stream as your GCP pub and sub, right? That's GCP pub sub, right? For the Azure guy, look at GCP, look at event stream as Azure event hub, right? And for the open source, like other open source like Red Pandas, look at event stream as Red Pandas. Some other people can also look at event stream as what they call it now as which other one? Kafka, yeah, your Kafka, normal Kafka too. So this one too also works like Kafka, right? Queuing messages and everything. And from there, you can also do your aggregation. So your aggregation comes for your consumer aspect. So look at your KSQL, the same thing as your consumer here. So KSQL stands for Crucial Query Language. This language was developed by Microsoft for streaming, right? So if you're someone that do a lot of streaming, right, it's also now available on Confluence. That's Kafka Confluence, right? So there's someone that like doing streaming a lot, right? There's something called KSQL, that's Crucial Query Language. It's available on some platforms like for some of us that work, some platforms like Log Analytics, Stream Analytics, Analytics, um, KQL, Data Explorer, etc. So for some of us now that are used to other technology, so the beautiful thing, what I'm not telling Microsoft though. What now Microsoft did well for that streaming aspect for KSQL is that they incorporated it to so many of their resources. So you can use it for log analytics. The same log analytics, just like AWS CloudWatch, right? Monitor things and everything. So you use like log analytics where you can monitor, you can create like a log for your runtime of you have your resources when the resources run. The start time, the end time, the failures and everything. So you can build like a dashboard around it. You have your stream analytics. So stream analytics is the same thing. So your stream analytics, stream analytics is the same thing as so I say KSQL. So this one is in Confluence, right? KQL, Kafka Stream API, right? Look at it also like I think this one is also similar to it also to your consumer Spark. Consumer Spark. Right, that's if you are using Spark as your consumer. So for consumer Spark, you have what we call your master and worker nodes, right? Master and worker nodes, workers, right? And also, what is the name of this one? The last one, and Fling, Apache Fling, right? So any of these, right? They can act as your consumer. So look at them. So what does Stream Analytics do for us? It gives you the ability to do things like aggregation, right? You can do aggregation. You can do your joins. So things like aggregation, the joins, etc. Right? So now this is how all the concept works together, right? You can have like your aggregation, you can have your join. So that is from the consumer aspect. So if you look at how this technology works, right, you might think, oh, AWS is too hard to learn. Oh, GCP is too hard to learn. Oh, OCI is too hard to learn. Let me tell you something, right? All the technologies are basically the same, right? Why may I have idea of everything? Because I've worked as a consultant, right? Sometimes as a consultant, you might get a job and they're using OCI, that's Oracle Cloud Infrastructure, Oracle Cloud Infrastructure all through, right? Or they're using AWS all through, or they're using GCP, or they're using Azure, or they're using open source. So I think that's the advantage why consulting comes, because you tend to touch a lot of things in the past, right? So these are the technologies, right? And how then can we now continue? Let me now continue, right? So now that's how KSQL comes to play, right? Then you can also have data going to Power BI real time. I won't call it real time, but I'll call it near to real time, right? Because it's nothing that comes real time. If anyone tells you something is real time, I say it's just near to real time. Sorry about that. It's just near to real time, right? You can have data coming in near to real time. Then we have what we call your data activator. To look at data activator like alerts. For some of us that are coming from a data analysis background, right? We use what we call alerts. So alert is just basically creating a threshold, right? So let me give an instance. So if I'm working in a company that will do sales, right? And my target for the end of the year is 100 billion US dollars, or let's say 100 million US dollars, right? And we've automated the entire process from data from maybe even data is coming from an on-premise. So we have like SSIS packages, which we are triggering with store procedure, right? We have SSIS packages that runs, we have data that picks the data using the gateway, those things, right? So data is just going like the normal flow process, right? It's automating the entire process. We are using the conventional approach. We are using things like cron jobs like Airflow, task schedulers, or batch files, all those kind of things, right? The logic is because you have automated your entire process, right? So, and your Power BI data set, or which they call it now. What's the new name they call it now? Hey, I know they've changed the name of data set. Semantic model. Yeah, thank you. Yeah, semantic model. Yeah, thanks a lot. So, for the semantic model, you can set what we call like a schedule refresh, right? I know for the pro license you have 8 refresh a day. I know for the premium per user, I think it's 48 a day, right? So one of those two. So if I set a like an auto refresh every 8 hours, if I'm using a pro license, or if I set interval of maybe in minutes, like 48 times a day, if I'm using a enterprise enterprise per user or enterprise per organization license, right? I know that the data set will be increasing real time, so the visualization will keep growing and everything. So the idea now is that I can set a threshold that, okay, as soon as my total sales gets to a particular threshold, that's if it passes a threshold, or if it gets to that particular threshold, right? Send me an email that, oh, congratulations, XYZ, you guys have met your target, or if you guys go below your target, right? So that is for the alerts, right, in Power BI visualization. But now this Microsoft created something called data activator. It's just like alert, but it works better for real-time stream, right? It works better for real-time stream and everything. Or if you want to go using the KSQL, you can also use stream analytics, which sends data to data set stream. That stream data set is something called a stream data set also too in the Power BI ecosystem. So now you can see how the data works now. I've touched core engineering, which is more like software engineers. I've touched data engineering. I've touched AI engineering. I've touched data analysis. So that's how the whole concept of engineering comes to play. Then what we'll call your data governance, right? So now, of course, we're trying to make a solution more production ready, right? What we'll call our data governance, which is using Purview, right? We'll call Azure Purview. But some people, they prefer using if you're coming for more of the what's the name now? From the data bricks, we usually call Unity Catalog a lot, right? But other people, they prefer using Azure Purview, right? So and for some of us now to do the normal standard approach, which is using the integrating with CDC approach, having your artifacts and everything. For security, we have what we call the enterprise ID, which was formerly called Access Directory, right? So they've changed now to enterprise, to Entra ID now. So they incorporated both Microsoft 365, Azure, and Power Platforms and other things together. The DevOps, so if AWS DevOps, Azure DevOps, anyone. For security, right, it's preferable you use a key vault, right, to make it more product ready. Use a key vault, and you have your Azure Monitor to monitor data real time, and you also have your Azure cost management, right? So these are all the technologies that can help you build like a CDC approach for real time. So now I'm using both open source technology and enterprise technology combined together. So now if I go a little big, so I'm advising everyone, right? Please, you can, they call it FORK, right? FRK, the repo, clone it, and please give it a star. Please give it a star. If I go clone it, give it a star. But I'll send the link again to the channel for some of us, right? And okay. So I've explained everything step by step, right? Setting up, provisioning all the resources, because for provisioning resources, you can use any approach. You can either use I know people prefer using an infrastructure as a code, which is everybody's using Terraform nowadays, right? But me, I'm still old school, so I prefer using CLI, Azure CLI. I use a lot of Azure CLI to provision resources and everything. Or you can use I know can use PowerShell, use ARM, that's Azure Resource Management, or you can use Bicep, but anything, or you can use do the normal GUI, click and drop. But me, I'm more of a code base, so I prefer using a CLI. So if you go through the article, right, that's the documentation, right? I've broken down everything, how you can go about it step by step, provisioning it, setting up the necessary resources, setting up permission. I want to talk about some things, right, that are very, very essential for us, right, to understand. So from there, I'll go to the coding. I'll just explain everything. So part of the things I want to talk about is called WAL, right? So when you're working with CDC approach for a database, right, it's always good for you to set the WAL level to logical, right? So there are two types. You don't have the logical, you also have the replical, right? So now from here, you can see that I've actually set it to logical. I'll show you how it works and how it is being done in the backend. But for some of you that have used the Belgium, you actually encounter this problem a lot. I know when I had the discussion with my wife back then, he said, "Oh yeah, yeah." He said wanted to even tell me something. And I said, "Oh, do you encounter WA?" He said, "Oh yeah, that's what I was trying to remember." So it's actually a very, very big issue on this aspect. So it's actually a very kind of issue. So I'll show you how all those parts works and how it's connected. This is actually optional. For production wise, please don't do this, but this is optional. So why did I add this to it? I just want to like make any IP address have access to the database. Like I said, it's optional. Please, for production wise, please do not do this, right? And setting up all the resources, setting up privileges, then there's code. Okay, so now you guys to clone the repo and use it the way you want to use it. So let me just go to Azure and open something first. And I'll explain what I mean by, so when you set up your Azure, you have set up all your necessary resources you need. Some of the things I need to check for, first of all, I want to check some things to confirm some things if they're working as expected. Yada, 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 yada. Okay, yeah, Postgres. Okay. Just give me a minute, please. Okay, so now we'll go to the server parameter. Always make sure so if you see the WAL, right? Please always make sure it is at logical, right? There are two types. From the documentation, I changed it to logical, but sometimes it might not change. But I know if you are going with if you are doing Postgres inside of Docker, sorry, I think someone audio is on, so it's echoing here. So if you are doing if you provision Postgres from Docker, you won't have this issue. But I know if you do it from a cloud resource like AWS, so you always come up with this issue. Okay, so let's go to, for everyone that's been following so far, what you just need to do now is to clone the repo, have it on your local machine, and we can start from here. So now I'll go to my VS Code, right? Okay. So in my VS Code, right, I have some, just give me a minute. Let me just open the Windows environment. So I named the the Python virtual environment as Python, right? So okay. So now in my Visual Code, right? Let's now look at the resources we need. So what are the resources we need? We need to provision some resources in Docker, right? So that's some Docker image. So what I did now is if you check that documentation, if you clone it, everything I'm using is here. So I don't need to now start writing everything from the beginning all over again. So part of the resources I need is part of the images I need. I call it resources. I tend to mix it. So resources is called on cloud. So images on Docker. Sorry about that. Okay. So part of the image I need or services I need is Elasticsearch, which I've explained. So Elasticsearch is a NoSQL database, right? It's just like your MongoDB, just like your Cosmos DB, right? So I'm using Elasticsearch for storing my data, right? I'm using Kibana for visualization, right? And you can see the Kibana version I'm using and everything, right? I've also set all the port name, the port numbers and everything. Zookeeper. So I'm not using for this one, for this particular project, I'm not using Confluence, right? I know Confluence is what everybody uses right now, but I'm using what's Mister. For some reason, I just prefer using it. But if I'm doing like real project wise, I use Confluence, right? It's preferable. That's Kafka on Confluence on cloud. It's preferable using that one. But this one I'm using Westminster, right? But you can use Confluence if you want to use Confluence. And also, please, this is actually a bad practice I did here. I will tell you where it is bad, where it is not bad. Why is it bad? I'm using the latest image, which is not good. Always use a particular version of image. It's always preferable use a particular version of image, right? So for this, my Zookeeper, I'm just using the latest. This is a bad practice for using this. If you notice, I used a particular version here for Kibana. I also use a particular version here for Elasticsearch. Please don't use the latest. Most times, it means that for the next one now, for let me say like a month after they release a new version, I'm always going to use the latest. If that latest under is not like generally supported, I always have issues. So, because this is just a dummy kind of presentation, so you guys can always play around it, right? So also for the Kafka broker and everything, right? I've set my ports, my inbound, my outbound on the local host. So currently I'm using a local host, right? But if I was using Confluence on cloud, though, I'll have like a broker URL, like a broker URL ID that can just connect to it. And lastly, this is your Debezium also too. So your Debezium, I've said what Debezium does, right? It does a CDC approach for me. So currently now my Docker is running. So if I just do my Docker PS, right? Just to see all the Docker that is currently running right now. You see that my Zookeeper is currently running, my Kafka is running, Kibana, XYZ, all of them are basically running. But you can also check it from your Docker desktop, right? And I'm using Windows. So for me to use Windows, I have what we call WSL installed on my laptop, right? That's Windows subsystem, Windows subsystem for Linux environment, right? So please, well, and if you're using a Mac, if you're using Linux, you don't have that issue. But for guys using Windows, you might need to install WSL, that's Windows subsystem for Linux, right? So please install it before you use it, right? So now if I go to my container, right? So okay, this one is so this is Kubernetes. So I change it. Okay, take this one, yeah. Okay. So for my container, yeah, you see that I have multiple images that are currently running, right? I have my Zookeeper, I have my Elasticsearch, I have my Debezium, Kafka, Kibana, XYZ, right? So all my images are currently running and is working fine. I've set all the necessary things I need to set. So next thing I need to do now is, okay, now, remember from the image architecture, right? One producer, right? An application that sends data real time to a database. But now, because of I don't have an application here right now, right? I don't have an application running here right now. What is that? That's something I don't like about what do you call it? About Teams. That stuff that comes up, it just stays there. It don't let you come away from there. Okay. So if you look at the architecture again, remember now I have a producer, right, that sends data to Azure Postgres database. But because now I don't have an application right now, so I'm going to mimic the scenario of a producer. What am I mimicking? I'm mimicking like an application, like a web application. So what I'm going to use now, I'm going to use a Python code as my producer. So this part here is going to be like a Python code, right? I'm going to use a Python code for this idea. A Python code. The Python code will be used at this idea, right? It's going to be mimicking my producer, which is sending data to Azure Postgres SQL database, right? So that's just step one. Then I have my data comes to this point here, right? Then I have my Debezium that capture the data real time using a CDC approach, which is exchange data caption and sends those data real time to Kafka topics. So, okay, so let's go. So and also all my security has been dropped here. That's all my credentials, just doing the best practice. So on a normal production wise, I'll put my secrets and some necessary information in my environment variable. I would rather use what we call a key vault, right? Well, because of time and everything, I had to just pin this like yesterday night and stroke today again. I had to like redo everything again because I know I've done before in the past for someone. So most times you don't put, I'm not going to click here because of some credentials are there, which I don't want it to open right now. So, but just best practice, have an environment variable, right, where you store all your credentials, like your password, your username, your connection strings and everything, right? You store everything in an environment variable, which is not part of this. So now if you look at the if you look at this one I gave the documentation, you see that I have an environment variable, but I've removed most of them. So if you look at this now, right? So the things that are actually in the environment variable is my database URL, that's the connection string name, right? I also have my Kafka Bootstrap, right? Bootstrap server. Currently, I'm using a local host because I'm using Docker on my PC. But most times you put it in a virtual environment, right? Anyone you prefer using, or you use Confluence on cloud. So I'm using a local host, and this is the port I'm talking to. That's 1993. Sorry. So for my accounts, so this was for my storage account. So for my storage account, that's my data lake Gen 2. I'll open it for you. So for my data lake Gen 2, the storage account name is this, right? That's Airflow data lake staging. The file system name, that is the container name. So it's called container in data lake Gen 2. It is called prefix in AWS S3 bucket, right? You call it prefix in AWS S3 bucket. So I'm using this also, right? This is the container name. Or you call it file system name. So when you have program, they call it the file system name. So also have a SaaS token, right? So for SaaS token, it gives you the ability to connect to the storage account. So most times people prefer using you can either use what you call a service principal. Service principal, right? Or you can use a SaaS token, that's shared access signature, that's shared access signature, right? So these are the things you can basically use. You can use service principal or self-access signature. Most times, right, it's preferable you should use a service principal, right? Because it is more standard. Because for service principal, basically what you're doing is that you're creating an application, right? You're creating an app that connects to ADLS, right? You're creating an app that connects to your data lake Gen 2, right? So most times people prefer using a service principal. But for service principal, there's a lot of commas there. So one of the biggest comma is that you have to have like an administrative right, because if you're working for a standard organization, you don't have the ability to provision resources yourself, right? So that's why you have to now meet the administrator, right? You meet the admin. That's either meeting the AWS, GCP, OCI, Roku, or Azure admin. Say, oh, you meet the Azure admin. Say, oh, XYZ, I want to provision so resources. You give them the reason why you provision the resources, XYZ. But if you don't go through that long route, you always use a shared access signature. But this one you can set it to have a start time and an end time. So there'll be a start time, that's a start date, and an end date itself, right? So it comes with it. So for that now, what you're going to have inside of it, you're going to have it's going to generate you what they call a shared a SaaS token. So this is like a SaaS. I just commented all those things out. So when you're doing it, you know what you need to do. And some other credentials I used was the event hub connection string and also the event hub name, right? Okay. Actually, I was meant to show you something in this comparison, but because of time and editing, I'm almost like an hour gone, so I don't want to like waste time again. So let's go into the coding part and let's see how everything works, right? Okay. So first of all, now the idea now is the producer sends data to a database, right? So and the database we're using a flexible database. Remember, we're using a flexible database. We're using a flexible database. There are different kinds of database, but we're using a flexible database. That's kind of database that's supposed for CDC for Postgres, right? So sorry, let me just change to the appropriate environment variable. Right? Okay. So now I want to run a producer. So if I go to the producer, let me show you how the producer works. So what I'm trying to do now, I'm picking data to me from a particular URL, right? And in that URL is just this, this URL here. So the URL is just basically random images, right? These are fake images, these are fake data. let me see if this is already working now. Okay, cool. So these are fake data, right? These are dummy generated data. They are not real life data. So no sensitive data is being shared right now. So whenever you refresh this, sorry, I'm drinking what I'm kind of have a sharp pain with. Okay. So now, if I'm just picking data from an API, right? Just a random API. So the API is just like random image API. For this, right, it just generates random image. None of these are real life data. So if you see your name there, please, it is AI generated and not real data. Please don't say, that is my data. And so from this JSON file, right? There's some key information I want to get. Like I want to get the genders, I want to get some other things. That's why I created like more like a dictionary, right? Or more like an accepted list of data I want to see. Like, okay, I want to get the name, I want to get the gender, I want to get the address, the latitude, longitude, time zone, email, phone number. Like I've actually brought out the data I want to capture, right? That's like the user data itself. So now what happen now is if I go to my database, right? So I'm using for some of you that prefer using the Belgium, right? So now if I just run, let me just count it first of all. Okay. Connect. Sorry, just give it a couple of minutes. Okay. Now so I'm 143, right? So remember, I'm picking data. I have to put like a delay in the code itself, right? Just to like give an interval, like okay, wait every 5 minutes, then send the data, wait, send the data, just to give like I'm trying to like simulate like a real world scenario, right? So now if I run this again, okay, 173. So you can see it is increasing, right? So the next thing I want to do now is come in. Next thing I want to do now is if we go to let's go back to the architecture itself. I'm using architecture to explain everything for us, right? So I know our data now is entering here real time, right? It's entering here now to database. Now to capture the data now using the Belgium, right? The Belgium is an open source technology that gives you the CDC approach. Remember, we have set up the Belgium inside of our Docker. Because everything is out inside of a Docker, inside of a virtual machine. Or you can use your EC2 instance on AWS, right? But this is Azure virtual Azure virtual machine, Windows virtual machine, right? EC2 instance, if you're an AWS guy, anyway you prefer using, right? Everything works end to end, right? So now I'll go to my Debezium UI, right? So my Debezium UI, I've actually set the connection already, but if I want to create a new connection, I'll just say create a new connection, right? I can do connection for any of these, because I'm using Postgres, I'll say, oh, for Postgres, right? I give it the connection name, I give it a topic, the host name. Remember, your host name is your server name, right? Username, basically you guys already know my username, Timidayo, and password XYZ. Then most times there's something you have to also check, right? Always change this plugin to PG output. Please always use PG output for this aspect. Then you test your connection, then to work. And make sure you're setting the table itself, right? But because I've already done the settings already, right? So let me just go back. It stops. Oh no. It's taking time to do. Sorry about that. Okay. So right now I have a connection running right now. It's working as expected, right? So what I can just do now is to check if my connection is working. Let me check for all the Kafka topic itself, right? So topics are just more like tables, right? I'm picking data from the database. I'm sending it to Kafka, right? I'm sending to Kafka topic. Look at Kafka topic as a table of your SQL database. So if I'm sending like a sales data, right? If I have a sales table, I'll send that sales table to Kafka, right? I'll create like a table called, I'll create like a topic called table or sales, right? So I'll send it, the data to that table itself. I'm using hand to explain, sorry. I'll send the table. Let me come again. Okay. I have a table, like I can have a schema in a database, right? In that schema, there are multiple tables. You can have your views, your tables, your stored procedure, different objects of your database in the schema itself, right? So in that, one of those tables is called sales, right? So if I was to send that table of sales to Kafka, right? Most likely I'll create a topic called sales topic in Kafka with the necessary partition and replicas, right? Then when I'm sending that data from the producer from the table itself to Kafka. We'll just send it directly to sales topic. So now just have the idea that a topic represents a table. I think that's the easiest way I can explain it so far. So now I already don't know the connection, so it's running. I don't want to open it because if I open it to show you like my credentials, which I'm trying to avoid right now. But that's all of this, right? It's working as expected. So what I need to now do now is let's now look at all this. So you can see the name is the Belgium underscore connection. That's Debs underscore connection. So if I go to my code itself, let me just stop this for now because this is still run. Right, let me come here. Right, I'll paste this here. So now if you look at this, I'm trying to list out all Kafka topics, right? So I said, okay, Docker compose execute Kafka topics.sheet, right? List out all the topics in this Bootstrap server, which is Kafka. The port number is 1992, right? It's going to list out all the topics under this port itself. So if I run this, right? So list out all the topics here right now. Let's just give it a couple of minutes. Okay, awesome. Okay, now you can see all the topics here, but the topics I'm actually looking for, if you notice very well, there's a the Belgium connection I called Deb, right? And if I go to my the Belgium, you see that I have a table called fabrics. The user, I just gave the username, user data as a table name. Don't mind me. It's not standard. I'm just naming it anything, just for time and everything. So now you can see that this is the exact topic I'm currently looking for, right? This is the topic I'm currently looking for itself, right? So what I'm going to do next is I'm coming, just a minute. What I'm going to do next now, okay, let's say that, okay, I can see this is the topic I'm looking for itself, right? So let's now say, let's try and consume the data itself, right? Let's consume the data from that particular topic. The name of the topic is devs underscore connect dot fabrics dot user underscore data, right? So let's try and consume the data from this particular topic itself, right? So how we're going to do it now is, if you look at this now, right? Sorry, I can't put all this in my, so I kept the scripts at another screen here, so I can't be cramming this in my, sorry. So I will explain everything to you guys so you guys understand how everything works step by step, right? So now what I'm trying to do now is I'm using a command line interface to consume the topic itself, right? So I'm saying Docker compose, right? Execute console consume. So I'm trying to consume data that has been sent to that topic, right? And the name of the topic is deb underscore con underscore. I'm consuming from the beginning. From the beginning means I'm starting from the beginning, right? So from the topic, I'm starting from the beginning itself. So I'm starting from the beginning. So if I run this now to tell me to consume all the data in that particular topic from the beginning itself. So and stop. But this now is made. I'm just trying to check if Kafka is working as expected. So I'm testing from the command line interface. Okay, I can see that it is working as expected. Awesome, fine, great. Okay, let me just close this. Let me cancel this connection for now. Okay, so a total of 182 messages were consumed so far. Let me check. Let me confirm if it's the same thing with what is here so far. This might even be more or lesser. Okay, 182. I think it's 182 also here, right? 182. Okay, awesome. It's the same. Cool. So now the next thing to do now is let's now talk about now that data now is going to, I'm pushing data real time to the database, right? From the producer to the database. I'm consuming the data because I've set the connection for the Belgium. Sorry, I couldn't show the connection because I have some sensitive information that I don't want to share. That's my personal Azure, which I don't want to give out, right? So I don't have to start creating another one, another resource that I can show, but it's still the same process. But if you go through the GitHub documentation, I explain everything in total, so you can see how everything works in total itself, right? So the next thing I'm trying to achieve now is if you look at this very well, I can consume the data, fine, awesome. But let me go to this thing now to explain better, so it's easier for me to explain. Okay, cool. This thing is always very annoying. Sorry. Is this team stuff? Okay, so now I know that data now is entering is entering Kafka, right? I've tested it using the command line interface, right, to see, and you can see that, oh, data is entering. I can consume data. So I know that, yes, data is now entering into the Kafka topic itself. So what I need to do next now is to consume the data into Elasticsearch and also consume that data also into a data lake, right? So I'll create another consumer script. Remember, I told you that there are different ways of consuming. You can either use KSQL, you can use KSQL is on Confluence, right? That's Kafka SQL on Confluence. You can use Kafka Stream API. You can use Kafka Consumer, which I'm going to use right now. It's a Kafka Consumer. You can use Apache Flink, which I prefer using Apache Flink actually. It's like the best. To me, I think it's the best so far. I don't know, but to me, I love using it more. Or I can use second, followed by Spark, right? Apache Spark, right? So I have to consume that data to push it into Elasticsearch, and also to send that data also into Azure Data Lake Gen 2, or you can call it S3 bucket or your Google Cloud storage account, right? So now what I need to do first of all, I need to create like an index, right? I need to create an index. So let me just get it from here, because right now I don't think I have here to create index, but everything I'm using is actually in the code, right? So I'm coming, let me just, the script is kind of long a little bit, so just copy this, right? So I'll go back to my VS Code. Let me just create a new terminal, right? You know, it is always bringing out red pandas all the time. Fabrics. I mean, I shall just press stop. Okay. So now to enter inside of Windows subsystem for Linux, right? So I'll just say WSL Ubuntu, right? Do, 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 do. Puno, 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 puno. Okay, cool. Okay. Sorry, it's coming. Okay. So now let's say I'll create an index, right? I'll create an index inside of what is the name now? Inside of Elasticsearch, right? So now how do I create my index? There's a script here. Let me just drop it. But actually, everything I'm doing is already inside here, right? Everything I'm doing is inside here. If I search for index something, yep, that's it. So this is what I'm currently writing right now. This is the script here. This is just the thing I'm writing right now. Right, so right, I'm creating an index, right? The same way too, if you're using Cosmos DB, you create an index. If you're using MongoDB, you create an index, right? So I'm creating an index, right? And that index name is called user data underscore index underscore new, right? And I set a replica factor to 1. And also I tried mapping it. This is not a good practice because of in a scenario of things like schema evolution, right? It's not, this approach will not be good, but I'm just mapping it for now, right? So now I'm mapping all the different columns I want to see in my index, right? Or fields. I'll say the gender, address, latitude, longitude, time zone, email, XYZ. And I also added the data types into it, like, okay, insertion dates, the dates, date of birth, the date, some other one, a string and everything, right? So now, what I'll do now is, if I run this, right, I'll just run this. It should tell me that I already have the topic. The topic is already existing actually because I have the topic already inside. So let's now start to confirm the topic itself, right? So let me just run this script here. Sorry. Yada, 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 yada. Let's run this to confirm if the script exists, right? I can see now, tell me, okay, the script exists. So now how can we see the script ourselves? How can we see the index ourselves? So we're going to go to what we call Elasticsearch itself, right? Where's my Elasticsearch now? I hate this thing, I swear. Okay, yeah, this is it. Okay, okay. Developer soon. Okay, cool. Okay, okay. Okay, so this is my Elasticsearch, right? So what I need to do now is I need to first send data from so I need to consume data from Kafka topic and send that data now to Elasticsearch. I'll insert it into Elasticsearch, right? View from the architecture itself. So any questions so far? I don't know, like, is it getting Is it getting too complex?
No.
Okay, yada. Okay, cool. So what I'm trying to do right now is the data is very in Kafka topics, right? I want to consume that data and insert that data into Elasticsearch itself, right? So now what I'm going to do now, I have another script. Remember, I told you that there are multiple scripts can use for multiple things, but I'm using a consumer script from Kafka. Please, everything I'm doing, if I say actually from the scratch, it will take time and definitely there'll be bugs and everything. So that's like, there's a GitHub repo, you guys just clone it, but before you clone it, give it a star. That's just my own. So you guys can clone it, you guys can use it, do whatever, anything, build whatever thing you want to build around it. Be something amazing actually. So what I'm trying to achieve now is how to insert that data now into Elasticsearch index, right? So now I have a Python script that does that. So actually I have multiple Python scripts. So I'll look for the one that does it. So that is Elasticsearch, yeah. So consume Elasticsearch. I've given it like a naming convention, so I'll easily identify it. Okay, cool. So what I do now, let me just try something. I will run this one, the producer. I'll be running the producer, right? I will also now run the Python consume, not ADLS for now. Elasticsearch, yeah, cool. Oh, sorry, I didn't spell it wrong, sorry. It is consume, not consumer. Okay. So consume, cool. So now, what's going to happen now is that, okay, now, data is being consumed and it is being inserted into the Elasticsearch index, right? And at the same time, I'm also producing data also. So data is also, I can start some intervals here, right? Data is also being produced, right? And it's inserted into the database, right? So now what's happening now? I'm running both the producer and the consumer the same time now. So if I go to the architecture, let me explain what's happening right now. Remember, my producer is a Python script. So Python is pushing data into here real time, right? As data is entering here, the Belgium is doing a CDC approach and taking the data to the Kafka topics, right? I also have another Python script that consumes data from the Kafka topics, which is that topic name, which is that the del underscore consume dot fabrics dot blah yada, right? So data is being consumed and inserted into Elasticsearch, right? Real time. I also check the Elasticsearch, but I also want to explain what's happening right now. That's what is happening right now. So now let's now go to my Elasticsearch and let's now see how the data is being entering now. So let's just say count. So I'll go to, sorry, I like using the word yada. It's just easier that way. So let's just count, right? So you can also count in this if you're using the cell I, right? So let's just count it here, right? So if I count now, right, I have 271 records right now inside of my Kafka topics. I mean, record was here the other time. Want something? Let me see if it has gone more than this. Okay. Oh, okay. I think I know what happened right now. Sorry, I didn't close down this one. I had something I tried earlier today, so I think it just added the same data. But sorry about that. I should have started all over again. I didn't create a new index. That's why. But you get what I'm trying to explain, right? So data is entering inside here to real time. So if I run this again, it should have increased down to 276. I run again, 27, and so on and so. So I can also check, let's say how to see the views of the data, for instance, right? Let's say how to view some of the data now, right? Run this, say run, right? So now I can see, okay, these are all the data that are entering. So the idea now is that for core engineering guys, what I mean core engineering, I mean the software engineers, the backend guys, that want to like have a feeling of, because it's not only data engineers that use data, right? There's software engineers. As I keep saying that, I'm looking at the future right now. The way I'm seeing the future right now, I think it's just software right now, because software guys are like the real data people. That's what I see right now. I'm just saying what I think. I might be wrong. I'm not a wizard. I'm just saying what I think. Okay, I think I got something. Okay, sorry. Okay. So yeah, I can see the data coming here, right? Real time. I can see all the entire data and everything. So I think for the first phase, we are good, right? From year to year to year to year to year. Cool. Okay, let's now do the Kibana aspect, right? So for the Kibana, it's just, you can also get Kibana from inside the Elasticsearch itself, right? So if I go to, so if I check my discovery, for instance, right, I'll see all the data here now, for instance. And you can see now, you can also write KQL, right? Crucial query language. It's called Crucial. Let me get the full meaning. KQL in Azure. Right. Yeah. Okay. Cursor query language, right? It's actually for stream. It's on Microsoft Fabrics. Yeah, it's very, very popular in Data Explorer. We use a lot in Data Explorer. So that's cool. That's cool, I guess. So okay. So now you can see the data now, right? I can also see, okay, let me have like a better pictorial representation of the data itself. I can see, okay, these are the different tables. I can see it in a table format. I can also see it in a JSON format, right? Okay, cool. So you can see all the data in the JSON format itself, and you can see it in a table format. So now there are different formats on how you can actually see the data itself. Okay, and I think there's some image. Let me check the image. I think they're a random image actually, but let me just confirm. Yeah, they're random image. They're not real image. So don't none of this data is real. So if you see your face, it is AI generated, I guess. Oh god, technology is so interesting. Okay. Let me check here again. Let me just confirm. Yada, 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 yada. Okay, cool. Okay. Okay, so I have all the data I need now, right? So if I want to create like a visualization or something very, very easy, I come here, I go to dashboard, right? And let's create a new dashboard or something. Create visual. Okay, let's say gender, for instance, right? Let's drag gender here. Right, get a pie chart or something. So now I can say, okay, I can do a comparison now. The data is entering, remember, the data is entering real time, right? So now I have a percentage between, so the male is 5.2, 5327, 53.7. So 53.27, 53.27. Let me try and refresh. Let's see. Is there a place I can refresh from here? 53.2. Oh, no, 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 no. There should be a place I can refresh from here. Man. I don't want to scatter. Let me try first. Let's see. Refresh 53.27.
So check the lower right hand corner. There is a
Oh,
refresh button there.
yeah. This is it here also. Don't mind me, Joe. Thank you very much. Okay. I just like this. I think that does increase. It was 53 point. That is 53.25. Oh, yeah, cool. Yeah. Upper right. Upper right. Yeah. Don't mind me. I'm always looking at screen a lot. So okay. Cool. So now we have all of these. So I think to a good extent, right? We are good to all of these parts here, right? So now let's not say I remember I told you that for data scientists, they don't like the data in tabular format. If you want call data scientists, they will say, "Oh, I want data in a file format." If you want, if you even want to give them in a tabular format, they'll prefer a what's the name of this SQLite. They say, "Oh, they prefer SQLite than using normal relational table," or they use what they call Pinecone DB, right, or vector database. You call it Pinecone database, right? We are doing like Pinecone. In fact, building things like RAG models, right? You are doing like RAG models like LLMs and the rest, right? They prefer using Pinecone, right? Is it Pinecone DB? That's a vector database, right? So they prefer using vector database and some other things, which is amazing. But I know Postgres actually did a lot of development recently, and they're really going into the database aspect. But if you are in the Azure route, you usually call what do you call this stuff now? Azure Cosmos this thing Azure right, AI search, right? Yeah, it's called AI search, right? It's called Azure AI search. It was called cognitive search formerly. It was previously called cognitive search. Sorry, all those names are really confusing. So we call it Azure AI search, right? Or call it cognitive search, right? So before it was formerly called cognitive. What it basically does, it does what we call an index. It index data and gives you multiple fragments. So now it just helps you break down data. So if your ability is like a How will I explain now? So let me say, if I be like, hey, I'm trying to explain this, so explain how the data AI engineers or they use their own concept, right? So I'm explaining this aspect. So let's assume that I have a data in a storage account, like an S3 bucket. So I'm using an S3 bucket as my storage account, right? So what I'm going to do now is I need to index those data. So I use what I call the cognitive search, AI search, rather. AI search, right? So what I basically do, I index the data. So what indexing basically means I'm breaking out those data into multiple fragments, right? So from indexing, what we'll call, after the indexing, you now take it to Azure OpenAI API. Azure OpenAI Studio, right? Where you can build your APIs or use an Azure Open, you guys an OpenAI API or something, right? So that's how if you're going through the enterprise route, then you now go to your outputs. That's your business users, right? Yeah, I think this basically this just gives like a flow, right? S3 bucket, you have your AI search to index and break down all the informations. Then when you break down all those information, you take it to OpenAI Studio. You can now from that OpenAI Studio, you pick the kind of model you're using. Are you using ChatGPT 4.0? Are you using 4.3.5? Are you using 4.0 mini? Or are you using like different types? You pick the different types of the model GPT model you want to use, and voila, you build a solution from that, and something amazing. So this is the route of enterprise, right? But now I'm talking about route of open source. So for the AI guys, right? Because I have a lot of AI friends. Actually, I have a lot of AI friends. I also am an AI guy to myself. So for what we do most times is we rather prefer the data in a file format, right? So, but some of them, if they're really, really going big time on open source, there's what called Pinecone DB, and they integrate Kubernetes to orchestrate data process on Docker. It's a very long process like that, but let's don't go. We're not doing AI solution here. We're just talking about architectures. So the data comes here now. So I'll create a consumer that sends data to data lake gen 2, and I have a pipeline. If you don't use the pipeline, it's fine. You can actually use a Python from here and start connecting to it. But I also want to show that you can actually go on an extra level ahead, right? I'll create a pipeline, but this is optional. These two are optional. You can do your AI, you can put your Python script from here, start connecting to your data lake directly. You don't need to go through this route, but I'm just showing that you can actually go a step further, right? So now I created a pipeline, right? So there will be a pipeline. So this pipeline is called a Fabrics pipeline, or you can call it AWS Glue, or you can call it GCP Fusion, right? Or in the Azure, call it Azure Data Factory, right? Or Synapse pipeline, or for some of us that are old school, SSIS, right? It's for the whole idea for data factory is basically SSIS, right? Data factory was actually from SSIS, just took it to the cloud. That's SQL service integration system or something. That's SSIS. So some of you are like, yeah, because of MSBI developer, right? SSIS, SSAS, SSRS, Power BI, or configure the paginated report, and those kind of cool stuffs. Okay, so now I have my pipeline that picks data, but picks data incrementally, right? So now there are multiple ways of doing incremental data, right? I can either pick data using so for incremental, I can also call the last modified date approach, right? I can use the stop procedure approach, right? Where you write an SQL script that does a comparison. I can use what we call data flow with the offsets, right? Offsets. I remember the concept of offset. Offset is broken down into two things. Offset is called updates, and insert, right? So update means that the way you do updates in SQL, right? Update means I'm updating a value that already exists before. Insert means I'm inserting new records, right? So it's called offset, right? So now if you're doing that offset, if you're doing it on Spark, we call it merge, right? We call it merge, right? But if you're on SQL, so we're actually a Python script, you say, merge, you merge this and that. So it's actually a very interesting code to write, but that concept is what you're going to implement here, right? So now, the next thing now is for the pipeline. So let me first send data now to Data Lake Gen 2, right? So for my Data Lake Gen 2, let me use Data Explorer, for instance. Okay, let me first delete this. Okay, so I want to delete this. So I'll just start it all over again. It's easier. So I'm in my Data Lake Gen 2. Yep. I hope I'm still audible. If you guys have not left me. Okay. Muslim, are you guys still here?
Yes,
Yes, we can hear you. You're still audible.
Okay.
Following along.
Oh, cool. Okay. The fabrics here, cool. So now let me have another script now that consume data now from Kafka topics and sends the data to Data Lake Gen 2. But remember, I'm using a SAS process. That's SAS. That's a shared access signature. How can I generate a shared access signature? Is you can do it from your storage account, right? If I go to my this thing, right? Sorry, just give me a minute. Okay, yeah, I think it's from security. Yeah, security. You see shared this thing, right? You see your shared access signature, and you can always generate a connection string, and you set it. I just put everything, but it's not good to highlight everything. You just pick the one. Maybe you want to just do a write and a read. Don't put delete. Don't do all those things. I'm just it's my account, so I can do it. I want to do with it. So, but on a startup, if I was an administrator, like an Azure administrator, right, I won't give the person. If say, oh, I want to have like a SaaS, that's SAS approach, right? I won't give the person all these access. I will just give the person only maybe write and read, list some table and some other things. But I won't give the person all these access. So what I need to do next is you can also generate it also too from your Explorer too, right? Then you right click, you go to get a shared access signature. You set all the protocol, you create. So anyway you prefer doing this, both basically work the same way. So it's a win-win though. It's a win-win. So let me go back to Visual Studio Code. Let me yeah, I'm here already. So let me Python consumer ADLS run this. Okay, okay, yeah. So now remember I deleted our folder, right, called random something, right? So if I go back to my data lake, I should have something called random stuff. Let me refresh this. Yeah, random JSON. I just created a folder name. Yeah, cool. I can see what's the time now, 6:20. So these data are entering now real time, right? So they're entering as a JSON format. So if I say, let me preview. It is preview for me. Let me see. Preview now. Yeah. Why are you taking time? Okay. If I download, okay, cool. So now you can see like it's giving like in a JSON format, right? So I can see do some cleaning and some other things to it. Like I can flatten the data, like flatten it, standardize it, and make it readable. So now I'm having the data. That's each records are entering into the data lake Gen 2, right? And you create a Fabrics pipeline to pick the data and move it and do something very, very interesting. So if I keep refreshing this, data should keep entering, right? So you can see it's still entering. So that is 621, right? Where's 621? Cool. So data is still entering like real time. So that's interesting actually. So if I refresh again, I want to enter like 622. So you guys just see how it works itself, right? But if I refresh this, okay. So let's go on, right? So now I can see that data is entering. So now data is being inserted now. So let's go back to the architecture again. So the architecture is like my source of truth of what all things I'm explaining so far. So you say like, oh, I'm scattering. Okay, now so I have one consumer that is inserting data into Elasticsearch. I have another consumer that is taking data into Azure Data Lake Gen 2, right? I have a pipeline that picks the data sent to data lake, file system, this, and this. So now let's now go to the other level now, because you guys are building a full solution. So let's go to the other level and continue the entire process. So then the other process now is, so recently Microsoft released a concept for CDC in Postgres, right? So it's called so they released a concept for CDC for Fabrics, right? It came out earlier this year, right? And which is very, very cool. So if I go to Power BI.com, which account is this one now? Okay, let me use this one. Okay. So the thing about this data, right? The thing I've seen about data is that you can't just say you are a data engineer. No. Because what I've experienced is that you might be like a core data engineer, but you have to have an idea of how data analyst works, how data scientist works, and also how database administrator works, because our universal language is basically data, right? So whatever data we're doing, data from here, all the data basically works the same. So I'm going to the workspace. So I think it's time that it has almost finished in the subscription. I'm using a free tier. So anyhow, so now our workspace, right? So what's the workspace? So look at the workspace as so when you say something is a workspace, right? Workspace. I want to explain the concept of, so workspace just is more like a container that houses all your Power BI resources. So it's a container that houses all your Power BI resources. So what are usually in your workspace? You have your data set, which they call semantic model. Actually, when they brought out the name semantic, it was actually I knew when they were hammering for to change the name to semantic model for the data set. I was like, so data set, you have your dash. I was list out some few things I know that are there. The dashboard. You have your reports. Yeah, reports. So that's just basically a summary of multiple reports you get. That's how you get your dashboard, right? You can have what you call your what's the name now? You have data flow, not data flow gen 2, but normal data flow. You also have your data mats. So data mat just basically gives you, it's more like a self-service solution, right? A self-service solution for building resources, right? So you have your data mats. What other thing again? What other thing? So there are a lot of you can have your fabrics, pipeline, your data legend 2, so on and so. You can also have your stream data set, right? Yeah, stream data set. So for this one, you see this one more where if you're pulling out the data from stream analytics, right? You see this more, you're pulling the data from stream analytics itself. So many things. So now a workspace, look at a workspace as a resource group, right? So resource group basically houses all your all your resources in a particular region / location, right? So it houses all your resources in a particular region or location. So the same idea for resource group is almost the same idea for a workspace, right? So just look at it the same way. They're basically the same thing, almost the same thing, but the same idea, not the same thing, but almost the same idea. So now, in my fabrics, I've created a workspace called Fabric CDC, that change data caption, right? So some of the things I basically need before I can do this, I need to have a KQL storage account, right? That I'll use for KQL programming language and everything. I need to have like an event stream. So for my event stream, let me just create a new resource called event stream, but I won't use that. I'll just create a new resource called event stream. Event stream. What is the title called is event stream, event of stream analytics. It's always confusing sometimes. Well, don't worry, we'll survive. Just say data engineering community demo, right? You can also check this preview as advanced. Okay. Trust me to buy, but I'm not buying. Let me stop all these ones that are running so that okay, I can still leave the consumer for now. Just say stop. Please stop, 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 stop. Okay. Can leave this one for now. Okay, so so now was I able to click the advanced capability? Okay, sorry, let me try something again. Sorry. I think I want to show you the part where they tell you can actually pull data from stream. I think I was meant to click. Sorry about that. Sorry about that. That's why Fabric is everyone likes Fabric. It's a low code, no code, right? Just plug and play, drag and drop. So that's why all data engineers don't like it. It's very, very funny that way, but it's cool. Microsoft want to make everything easy. But for we, I'm not. It's too easy. So event stream, it's too easy. Okay, let me just. I'll check the advanced capabilities. Let me just check it. So let's say data engineering demo. So sorry about that. I'm trying to get something. I'm looking for something. Most of it's in saved. Tend to come. Let it load first. Come in. How many of you watched yesterday's boxing match? You know if you watch Mike Tyson.
Yeah, I did.
Okay, cool. So where are you supporting? They beat Iron Michael.
Of course, Mike. The
That
legend, of
match,
course.
that match was a fixed match.
Yeah,
You
definitely.
can't. It was a fixed match.
Data.
He just went for the money. Just went for payday.
Okay, yeah. So this is what I'm looking. This is what I'm looking for. Let's hope this is what I'm looking for. So yep. Okay. So use external source. Let's click on this first. I don't know why it takes time to open. Sorry guys, it's loading. Okay, yeah. Okay, so now if you look at this now, right? Let me go back to the architecture now. This is the event stream, right? Look at event stream as Kafka. They're basically the same thing, right? But event stream, I said the event stream is the same thing as event hub. It's the same thing as AWS Kinesis, right? It's the same thing as GCP PubSub. They're the same thing, the same technology. It's the same thing as Red Pandas. They're all the same thing. They're all the same technology. Everything is basically the same, right? Well, now event stream is what we use in Fabrics, right? If I was doing it on Azure, which I will not do because it's going to be expensive. It's going to consume like the Fabrics. I would have used Azure Event Over. No. It's just a demo, so I'm just doing a demo for you guys. So I'm using like a free tier for Fabrics, so I can easily show you guys how it works. So if I was using event stream, right, it's still the same thing, but now event stream is just like Kafka, which is a topic replica, partition, and everything, right? So it needs a producer. The producer is going to be Postgres, right? Postgres will be a producer, which is going to be sending data real time in CDC. So now, Microsoft just added CDC for Postgres. That's part of the new feature it just released, right? So now, if you come here, I scroll down. Yep. So you can see different sources. You can see different CDC approach, right? I can see CDC for Cosmos DB, CDC for event hub namespace. Does it make sense? Okay, that was I'll be pulling the data from event hub down to anyhow. But I'm pulling the data from Azure event hub, which is also the same thing as event stream. Azure IoT hub, that's for guys that are doing IoT projects. So that one you have to use Azure IoT Arc, that's Edge Arc, right? Azure MySQL database, CDC's change data caption, right? Azure SQL database. So for SQL database, for SQL, you have three types of database in an SQL. You have the Azure SQL instance, which is the same thing with your SQL SQL Server on-premise, right? You have your Azure database, right? You also have your Azure Elastic database. You also have your Azure database for virtual environment, right? Okay, that's four, rather. That's four, rather. So that's four. So, but by using Azure SQL database, we also have your Azure MariaDB, Azure Postgres. So, of course, we're using Postgres, so use this one. So you can see that it's showing here that I have my um, server here, which is this, but I will not use this. Why am I not going to use this? Like a notice here, right? So there's a warning I gave you, or let's say observation. That it's like warning. They just give me. Let me just go to the CDC in. So when you build project, you discovered very interesting thing, because I actually used this. It was working to an extent, but I think I gave a warning. Okay, yeah. So yeah, there's an issue. Yeah. So I think this has been sent to Microsoft, so they'll just like look into it and see if they can do something about it. You get so, but it's actually a warning. So okay, I said issue with the CDC in Fabric's event stream, right? That okay, this feature is actually an amazing feature for CDC in the enterprise approach. The only issue I found was that Postgres database does not support multiple slots, right? So you remember when I was setting up the Belgium, right? So I've already created a Belgium already that connects to my Postgres database, so which is one slot. So now, if I do that same thing now for event stream, there will be a conflict in the data. Because why? The Belgium is already connected to the Azure Postgres database, which because I connected the Belgium first of all. So now if I connect event stream CDC to that same database, which is that Azure SQL database, there will be a conflict, right? So what I did basically was now create another resource for, but that's too much of money. So, but what I did, I deleted it, but I'm not doing it here, so because it's too much of money. But I'm just like telling you, because if you guys are reading the documentation, you will see it, right? I said that this feature is actually an amazing feature for citizen approach. The only issue I found was that Postgres database does not support multiple slots. The previous slot used for the Belgium connector affected the connection and setting for fabrics in Postgres. I had to provision a new server to solve this issue. So I mean I have to provision, but it doesn't make sense. You get. So what I now did was option two. Option two basically was I now created another application that sends data directly to what's the name now? To event stream directly. So I created a data that sends data directly to event stream. So why is it now? Let's now go
Hi,
where's my
Temidayo.
yeah.
I just want to remind you that we have like 25 minutes more.
No stuff. I want to do the AI, by the way.
Okay.
Easy thing. Okay. Yeah, that's noted. That's very, very noted, right? So now the whole logic now is so because of the way this is, right? Most times you can let me just say I want to just use a custom app, for instance, right? I can say I'll use a custom app. Okay. Sorry, just a minute. Okay, use a custom endpoint. So I can use a custom endpoint, right? Source name. No. Come, just give me a minute. I want to create an app. Is it from here? No. I don't want to use connection. Okay, shall I say if I want to use Azure Event Hub, right? But I'm not to use the Event Hub. It doesn't make sense. I'm coming. It's causing too much of this thing. Okay. No. Just cancel. Come, just give me a minute, please. External data. So let me just confirm something. No. This is a test. Test. Right? Okay. I'm coming. I'm just trying to do something. No, I'll not do this. Don't worry. You guys don't be scared. Okay, yeah. Okay, this is test, right? So if I click here, why is it giving me error now? Sorry. Okay, so let's do like this. Let me go back here. Let me create a new item. event stream. That's stream. I'm always forgetting all these things. That's the thing. Don't enable the advanced feature. Okay. Yeah. So I say custom app. Test. Okay. I'm just trying to get the there's something to generate for me, which is more like this is what I'm looking for. Okay. So another cool feature, I'm not running it, but another cool feature from this is that I can pull data from either event hub. I can put it from AMQP. I can also put it from Kafka, right? So if I'm putting, let's say for instance, I know that I want to pull data from Kafka, Confluence Kafka, and push that data to event stream. I'll just go to what they call keys, right? So for the keys, now you see the necessary keys like the bootstrap. You can see the bootstrap URL. That's the exit port. You remember in my Docker, mine was local, right? But because I'm using this now is from like more like Kafka Confluence. Like I see that it's giving me like a proper bootstrap server URL, the connection strings and everything. Then I can now send data also to this using like I say producer to event up. So I'll just stop here. That's all. Let me not make it too complex. So I think I'll stop here. That's all. Let's stop sharing my screen. I hope I didn't
Wow.
make it too complex. I don't want to make it too complex. Okay.
That was an amazing one. I was just screaming wow, wow, like an ambulance. Thank you so much for this amazing session. And all I can say is I've actually seen my next project. Thank
That's
you.
cool. That's
Thank
cool.
you. Yeah.